I'll begin with the first slide, the promise and the peril of multi-tenancy. The promise is definitely like once you go to before it went on cloud, everyone was on-prem, where there was a lot of security. Like there were because only the on-prem had only the servers which they are interested in. No other company had any servers installed on the on-prem. But then the whole cloud thing, when we started going to cloud, they started moving their infrastructure to cloud. So in cloud, there's an option to save money that you can have multiple tenants, like multiple servers, multiple hosts, or even for that multiple organizations hosted in the same cloud environment. So it is very necessary that we configure it correctly because the attackers, they what I believe is the attackers, they are not actually smarter. It's just the misconfiguration or the overlook what happens on the organization side. That is what the attackers take advantage of those overlooks, what has happened, and they get into the system. So once we go to the cloud and if there is multi-tenancy, then it is going to have a lot of lot of disadvantages where the attackers are going to try to attack. Also, there is a you can have like shared resources where you can share your resources, and that it also has these disadvantage that it creates a massive attack surface. So the core problem is if there is data leakage where one container sensitive data is exposed to another because they are all hosted on the they're all hosted on the same environment. So that is where the issue of multi-tenancy comes into picture. Uh, Customer misconfiguration, that is leading cause of breaches. If you do not properly configure your firewalls or the IAM policies, then if you do not deny by default, so even if an attacker gets in for whatever reason, but you have all the configuration in place, like the firewall are set up so that they don't get into the database, or you have the deny by default or the role-based access control given to your data, then even if the attacker gets into the system, it is very unlikely that they would have access to any of the resources. So I do believe that the configuration of your resources is highly critical. On-prem or cloud, we have to very carefully configure the ACM, the firewall request, the IP range, which has access to your application. And we also have to take care of the architectural flaws. If anything, the architecture has to be reviewed before it goes into the cloud to review if there are any architectural, if there is any flaw by design which the attacker can, take advantage of and try to get into the system. So this is a core problem which we are going to address in this presentation. So the tenant isolation is the set of security controls and technologies that ensure that the separation of resources, data, and access between different customers in a shared environment. So we have different customers into the same shared cloud environment. There are multiple cloud providers. The leading is AWS, we all know. And there is also Google Cloud Provider, where multiple organizations get into the cloud. But the definition of tenant isolation is that we isolate our data, our resources from different customers. So it is hosted on the cloud environment, but it is still not accessible to the other organizations. So there is something called a shared responsibility model, where the responsibility of your security lies with the cloud provider, as well as you, the one who is moving your application to the cloud, because it is a shared security model, shared responsibility model. So responsibility lies with both. You cannot just like rely on the provider to provide the complete security and misconfigure your application so it is easily be accessible to attackers. So it is a shared responsibility model which we should go by. The goal is to make the tenant's environment function as logically separate. So the goal is ultimately you want to achieve the same type of security as you would in your on-prem infrastructure or in a isolated VPC, isolated cloud. So isolated cloud is one option, but definitely not all organizations go for it because ultimately it has to be cost beneficial also. So if you are going for shared cloud, then it is very important that you have the shared responsibility model where you have some kind of contract with the provider that these are the things like depending on your model, whether the patches, who are going to take care of the patches. The firewall setup is definitely nice with the organization. The IAM policies, the access policies, that is attribute based or role based policies instead of the user based policies. So everyone is shifting from the user based policies to the role based and attribute based policies where you do not give access to any particular user. You give access to the role. For example, I'm going to cover that later on, but I'm just like, since I brought this up, for example, like when a developer joins an organization or your team, you should have a role. We all have a role as developers. So once the developer gets added to the developer role, by default, he will get all the access of the developers. So individually, the user will not be able to get access to one server, second server, third server. What is needed is you get added to the role and the role has access. So tomorrow, say if you move from the developer role to the testing role, they have different uh, privileges. So you don't remove all the access from the first and then give access to it creates a lot of confusion and there is a lot of, if it's not monitored or we do not have processes set up properly, then it is going to be a breach of the contract. So that's the reason we all, it's the RBAC, which is trending now. So the goal is to make the tenant's environment functional as a logically separate private entity, even though it runs on a shared resource. So when you're moving your architecture to a cloud environment, we all have to make sure that it is as secure as you would be keeping your infrastructure, your servers on your local on premises rather than, it should be like the end user should have like no difference between those two. So the team which is responsible for moving your infrastructure to the cloud should be able to handle or should have all these goals. So isolation must be enforced across different layers, that is compute, network, storage, identity access, and management plane. Uh, so all your compute resources that should be isolated. We can use, we on premises we have the virtual machines which are VMs. Once they move to the cloud, we have hypervisors which actually disintegrate the VMs. So that should be properly enforced. Then the network level also, like we should have the proper firewalls rule set up. Uh, as part, like I would say, for the banking and finance, if we set up an infrastructure in countries which are regulated, right, like Geneva or China, we also have a list of range of IP addresses which has access to the URL. So not every IP address can access the API. So it all depends on the sensitivity and the criticality of the data. But you can also set your IP address range into who is having access to your application. So that is all at the network layer. Storage layer is your S3, like the data. Make sure that you have proper access rights to your S3. It's not accessible by default. The common mistake when S3 came into picture was like the bucket was accessible by default. I guess that's where like everyone, when we were all learning and we were moving to cloud in the development environment, the one thing what we did, the common mistake from the developer's perspective was the bucket was, publicly available. So that is a major breach. So whatever there has to be proper segmentation as well. That the API talks to the middle layer talks to the database, but you cannot have an API directly talking to the database because it would have like a lot, it would give a lot of area or a lot of insights into how it can cause to the database. So your storage layer, your files, your storage layer is the one where you store the critical information. That is how you will have to segregate your network, your architecture. So you don't have, I mean, nobody has access to your storage level here. There is also like, it's not part of this presentation, but we did set up the VPC, that is the virtual cloud, private cloud. So in that we can also set up like these subnets, and they are the ones which actually route the traffic. So you can do a lot of controlling at the subnet level. Your inbound IP address and outbound IP address, you can configure it. Outbound is like not restricted mostly because like you're not like having access to internal. But inbound IP address, they have a lot of restrictions. It is denied by default. So we like the organization has to safeguard the storage level. The next is identity and access management. So I work at the identity and access management at JPMC. So, which is very critical. What we do is like, identify all the manual efforts and automate it, because automation is the key ultimately, because if manually you can have a lot of mistakes, but automation is, it is tested and you can also, as I mentioned, that the role is IAM roles are always, there is a RBAC and the EBAC policies. RBAC is like you give, it's a role-based access control, which I just explained that you give access to the role, then the particular individual. That helps in that helps in safeguarding your application. And attribute-based control is also very important because you give access to the attributes, like department is finance, then they have access to a particular storage. Rather than giving access to individuals, you give access to roles and attributes, and deny by default is the core principle. So even if attacker gets into the system, and if there is a deny by default, it will overtake all the roles, and that's where you can also stop the attack. There is a management plane. Every cloud will have a management plane, like where you can control your APIs, where you can control the configuration of the APIs, your cloud environment. There is a admin of every management plane. So, like not everyone has that responsibility and that access. So make sure that only responsible people have that access, because it is the most critical of any cloud environment. I'll move on to the next slide. So there was threats to isolation. Yeah. We have the configuration failures where misconfigured S3 buckets block storage or database firewalls, and overly permissive identity and access management roles, they are going to have the configuration failures. So I do believe that it is mostly like there was a breach in Capital One in 2019. It was because of a misconfigured AWS role. So it is rather than rather than the intelligence of the attacker, it is mostly the some misconfiguration and overload which has happened from the organization side, which has led to the breach. Architecture and software flaws like vulnerabilities in hypervisors, container engines. So we have, I don't know about the other organization, but from the one which I have worked on, there is a team which will patch the OS, the hypervisors, and will look for any updates which come from the vendors. So it is very important that you patch your infrastructure as soon as the updates are flowed into by the vendors. You cannot delay that because you do not know what vulnerabilities you are introducing into your system by not patching your infrastructure on time. So I know it is a bit annoying that when in the middle of the development cycle you are told to patch your servers, but it is what it is. But right now, like initially, I remember like before the cloud and infrastructure as a service, we had to have a proper downtime where bring down the application, and it was much handled by the application team. But after everything moved to cloud and we have infrastructure as a service, it's no more that pain of bringing down everything, patching it. It happens like at a click, and that's what the if any of your organization is not doing, then I believe everyone should go to infrastructure as a service because that's where you are going to safeguard your system. Side channel attacks, there is Spectre and Meltdown. So this is not like a I did not find or in my research any example which actually happened, but this is a vulnerability which they discovered in and then they were like Google came up with some several patches to fix that. So the vulnerability was that like if you listen to the configuration or the CPU settings, then there is a certain time where the cache usage increases or goes down. So that's where the attacker can actually listen to your CPU and make and find out like what is the time when they have a high load or the refresh is happening because every system has the refresh of the critical data which happens. So it was a vulnerability which they discovered and then there were several patches put to fix that. But if you do not, then it is a very high chance that the attacker can listen to your system and find where is the cache usage, where is the CPU usage going up and down, and then attack it that way. Then we also have the noisy neighbor attacks, which are very common in the shared resources, where a resource where one particular tenant will utilize all the resources of the shared. So there is no attack on the system, but the availability goes down. So that is one of the disadvantage. So you have to put alerts on when you do not have the proper availability into your system, so you can take care of that. But these are the threats to isolation that noisy neighbor attacks, sophisticated, the four which I listed. But yeah, these are vulnerabilities. We all have to like take actions to fix them. And by doing the proper patches, the whenever the vendor releases, we can prevent the attacks. So the hypervisor security, hypervisor is the bedrock, the minimal harm. So hypervisor is the one which actually separates your VMs, and the action item is you have to harden it like make it less flexible, include all the ACM, all the ACM rules. ACM are the firewalls rules, what you can into your hypervisor. So it doesn't matter that if any system, the neither system is not able to access your system, rather than everyone else is able to access. So you can address that. Like if someone is not able to access your system, then probably you can address that by adding that IP address to your list of accessible IP addresses. So make it more restrictive so you can protect your hypervisors in that way. The container isolation is also very important because they share the host OS level kernel, increasing the surface attack. So there are like gvisor kata containers and strict and app AMR profiles. I will just go into the kata containers. So they are the VM like isolation. So on top of your container, it is like a VM like container which will then talk to your host kernel. So that is the way you can prevent a lot of attacks, because that VM like isolation is going to block a lot of unnecessary attacks on your system. They are going to uh, monitor it, and only then you are able to communicate to the OS level, OS kernel. Even the app and they are similar type, where you isolate the API request and then you process the API request before it even reaches your OS kernel. So that's how you're going to take care of that. Then we have the confidential computing, encrypts data and uses CPU memory. So like encryption, we have to encrypt the data, and TLS, we can use several algorithms to encrypt the data in transit, as well as the one which you are using. And that these are the three ways you're going to safeguard your system. Virtual private networks is the first line of defense, creating a logically isolated network. So even in cloud, you can have your own virtual private network. It is, for the organization perspective, it is like your on-prem. So actually, you're not on-prem. You have like a provider, like the cloud provider has given you some space in cloud where you are building your infrastructure. But you need to safeguard it. So that's the first line of defense. So you build a virtual private network. And how do you build it? By the network access control list and stateful firewalls. So network access control list is the one which is having the subnets and the IP range. So you can define the IP range into your virtual private network. The network access control list will also will also safeguard it, because you are going to set all the inbound and outbound rules. Inbound rules are the ones which are coming into your system, like what IP addresses are accessible, and outbound is also what kind of data. Because if, say, for S3, your one of your bucket holds a very critical data, you don't want that to be sent to all the, no one can should be able to access it. So that will be an outbound rule, that you will make sure that this bucket does not send data to all of it. So it is restricted. You only send internally. So if you want your database layer to only communicate with the middle layer and not the internet, then you can set all those rules in the NACS, and that's how you configure your virtual private network, which is very critical. There are experts for that. It's not like, as simple as what I just mentioned, like two lines, but there are experts who do the virtual private cloud configuration for the organization. Then there is micro segmentation, that is identity based tools which allow only specific communication, and everything is blocked by default. Zero, like never trust, always verify. Make sure that the APIs communicate with the middle layer, and middle layer communicates with the database layer. You cannot have direct communication with your business data from the outside world. So you need to have layers on top of the thing, but you're protecting. Make sure you have the RBAC policy, the multi-factor authentication, which now all the banks use it. So we have to introduce the multi-factor authentication, which is a must. And that is micro-segmentation. You handle each layer at like not one at a time, and configure and safeguard each layer. Replace traditional VPNs with zero trust network access. That grants VPNs usually grant access to a wider range of network. So we have like many organizations that are replacing it with the zero trust network access that grants not to the entire network based on the user and device identity. So that is the way to safeguard it. So data storage, data and storage layer isolation, we have to use the encryption. All data must be encrypted. There are several algorithms which are provided by the cloud. I know about AWS, so because I have given my exam, so I know about AWS. So there are AWS S3. The keys are either managed by the customer or by the organization, but it is up to the organization to select that. uh, the organizations what I have worked on, the keys are always managed internally because your data is secure only as long as your key is secure. If the key gets compromised, then your data is not secured, so it doesn't matter. So I would prefer to have a internally key managed system, and the key should be rotated, maintained, and rotated. There should be some policies set up for the key that you should rotate the key every whatever your organization decides, and there should be control mechanisms for it to check if the key is rotated. If you do not rotate the key, then there is a high chance that the key will get compromised. So key rotation, object storage security, ensure public access blocks by default on all S3 buckets. Public access is blocked by default, and database isolation. Use separate database per tenant, but if the requirement is to use the same database across several tenants, then make sure that you enforce all the authentication and authorization methods and the database security as well. Key strategies are role-based access control, attributes, regular permission audits, and multi-factor authentication. Make sure we have the role-based access control. No one literally like user-based access control is totally outdated. It's a total breach if anybody is doing that. We have to go for attribute-based access control. For example, if department is so and so, and it is then you have access to particular rights. So if a user is having that attribute, or the role is having that attribute, then there's a second level of security like which happens for before actually accessing the resource. Regular permission audits. There are several tools which are provided by the cloud provider which can actually go through and go through even at the audit level. We do have like where there are audits to find out. There are automated processes to find out if an unwanted user is having access to any of the resources. The admin role is not given to anyone by default. And then we have the multi-factor authentication, which is equally important that you need to have a multi-factor authentication. The threat is the APIs, the cloud management plane, that is the APIs web console, is a high value target. A compromise here can lead to total tenant breach because the cloud management plane is the one which is having the admin rights, and it is where everything you are controlling into your cloud. For example, you're controlling the logs or how the internal APIs are flowing. So it is very necessary that you safeguard your cloud environment. So robust authentication, use OAuth and TLS, rate limit and monitoring of automation. Whenever if anybody, we have OAuth, I think everyone is using OAuth 2.0 for the authentication and authorization. So it is because API is the front end, like it is the where it is facing the users. So we have what I remember latest is OAuth 2.0, but OAuth is very necessary for authentication and authorization. Even if you are using some making some like demo projects for your university or something, I would also suggest that try using OAuth because that will give you a lot of insights into how that actually works. Then we have the console handling, restrict console access by IP address, enforce and MFA. Monitoring for logins. I think IP address is the one which needs to be considered because if you block at the IP address, and it is very you are safeguarding your application at the highest level because not like anyone can access it because now you have only given a certain range of IP addresses which your they can access your system. Infrastructure as a security code. In infrastructure as a security, infrastructure as a code, there is a lot of templates which are given by the cloud provider, or even the organization has their own, where you just have the template runs and your VM virtual machine or a machine in the cloud gets set up. So it's like, it's all automated, but it is very necessary that you have that template reviewed on and off, like maybe weekly, monthly, or I don't know what is the odd standard. But infrastructure as a code has automated, but it also has got into vulnerabilities that you can make sure that the code on which it runs, that is also patched. The code itself is having all the latest the all the vulnerabilities are taken care of that. So we do have to monitor the infrastructure as well as continuous monitoring and behavior anomaly detection is one of the things. There has to be aggregate logs from all the, depending on the cloud provider. For me, I have used examples from AWS, that is CloudTrail, VPC flow logs, and all. We have a continuous monitoring of those logs is necessary. And if there is any, behavior anomaly, like if you see someone like a lot of transactions happening or something at night, 3 a.m. or something, that is something which is not, or usually the system really has no network from 3 to 6, but you do see that, okay, now that suddenly there is a lot of user requests, the usage has gone high, and then have we use directories and AppDynamics for the usage of the computers and whatever the organization will do. So we have to see if the application doesn't usually have a high usage during that time, and it is now going high. So we have to verify like what is happening, what is the one which is actually taking up your system. This is defense in depth is the foundation of cloud security. Each layer reinforces next. So there is monitoring, detection, or the top layer. We have to do continuous logging, non-anomaly detection, automated alerts. Then we have data security, that is encryption and rest, and then use strict bucket policy. Encryption is one thing which is very interesting. We have those algorithms AES256, and we have several other algorithms as well. Something which I mean, I need to look into it deep as well. But hey, if anyone is interested, they can connect with me. But encryption is one thing which is very interesting. Data at rest and data in transit. So, which is actually safeguarding the actual flow into the application. Network controls, VPC isolation, micro segmentation, and zero trust network access. Compute protection is confidential computing, secure containers, workload isolation. And identity and access management is least privilege, RBAC policies, PII policies. Being a movie time and just, yeah, just 3 more slides. Yeah. This is again the same thing what I just mentioned, that we should have micro segmentation. Least privileged, that is your takeaway, like least privileged IAM, real-time monitoring, and automated responses. This is like, for your organization takeaway. Cloud service providers invest robust hypervisor for the cloud service providers. They should invest in the robust hypervisor security and confidential computing technology. Provide secure by default configuration with clear isolation guardrails and implement transfer monitoring and its capability. So the maintaining of but I do believe that we should go by the shared responsibility model, and there should be a contract done between the organization and the cloud provider about what all responsibilities will be owned by on the either side. And the main important thing is patching, and that should be never overlooked, because if you overlook that, then there are a lot of vulnerabilities which at the attackers are already aware that this particular version had this vulnerability. That's where the patching comes into picture. So if that is the case, then make sure that the servers are patched. This is just high school. That is foundation of trust, multi-layer defense. Just go through using one concept. This the last slide. This is my link code if anyone wants to connect further. That's it. Thank you.
Thank you.
Yeah.
Thank you so much.
I think we have a break in this room now. There's also one more pretty or it might have started already. If not, you can go grab earlier lunch.